So good evening. Today I am now going to discuss about logic gates. So before going into the quantum gates, we should know about some logic gates. So some basic logic gates. One is for the first one is nothing but NOT gate. Okay. So already you know uh, what is NOT gate, etc., etc. So it is like a inverter because it just does the opposite. If you give it a 0, it boldly says that it is 1. If you give it 1, it flips to 0. So the same input, if you give it 0, then you will be end up getting 1. If you give it 1, you will be ended up getting 0. That is what classical NOT gate do. So is that clear? So now moving on to the second concept, that is nothing but AND gate. So think of it like a teacher who says I will pass you uh, only if both answers are correct. Okay, so only A is equal to 1, B is equal to 1, the output becomes 1. Rest of all the cases, you know the output. Rest of all the cases 0. Okay, only in one case it is 1. Okay, that you should remember. So moving on to the another gate, I will make a quick recap because we can't invest much time in this classical gates. So moving on to another gate, OR gate. So can you, if you look it, the OR gate is like the friendliest one of all. So it says, hey, even if one of you tries, I will make it work. So if either A or B is 1, the output glows 1. So look at in this scenario 0 0 0 because no 1 is there in this particular scenario. If it is 0 1 1, if it is 1 1 1 and 1 1 1, in both the cases, in all those three cases, you will be ended up getting 1. So this is about OR gate. And moving on to the another gate, that is nothing but NAND gate. So it behaves exactly opposite. Okay, for AND gate. So it checks AND's rule, so then it flips the answer. So it gives a 0 only when the both inputs are 1. So please look, if the both inputs are 1 in this particular case, you will be ended up getting 0. If the input is 1 0 0 1 and even 0 0, the output you are getting are 1. Rest 1 1, then the output will be 0. That is what the NAND gate. Okay, so moving on to the NOR gate. Okay, the NOR gate is the quiet one. It is like, it likes silence. Okay, if it gives output 1 only when both inputs are 0. What is that? Even when the both inputs are 0, then only you will be getting the output as 1. In rest of all the cases, you will be ended up getting zeros. That you need to remember about the NOR gate. So moving on to another gate, XOR. So the output is 1 only if inputs are different. What does that mean? If output is 1 only when inputs are different. Okay, here the inputs are same, so the output is 0. This is not 1. Here the inputs are 0 and 1 and the output is 1. Here the inputs are different, the output is 1. Here the inputs are same, so the rest is nothing but always you know that is nothing but 0. So moving on to XNOR gate. So if you look the explanation that I have given here, output is 1 when both inputs are the same. So only in one scenario, only in two scenarios, the both inputs are same, 0 0 and 1 1. So rest are zeros. Okay, if the inputs are same, then you will be ended up getting 1 1 as the result. Okay, so this is about some classical gates. Okay, this you can write in your exam. This is sufficient for representing the difference between classical gates and quantum gates. Thank you.